It's always such an honor to spend time with you and to be together. If you're brand new, welcome to this channel. And I also want to take a moment and just acknowledge you for taking time to listen to something that can truly help you in improving your solving skills. If you are super stressed in solving, the tip that I give are short, concise of how they can be better and improve your solving strategies. And today's topic is on estimation from statistics, and these are the few problems which are repeatedly asked. So here is an example, solved example here. In a study of an automobile insurance, a random sample of 80 bodies. Here the sample means n is given. Repair cost had a mean of 472.36 and the standard deviation of rupees 62.35 if x is used as a point estimate to the true average repair cost. With what confidence? So what is it is asked? So we have to find the confidence. With what confidence can you assert that the maximum error? See here, the maximum error value is rupees 10. So here, what all are given here? So the given items are n. So n, the sample means n. N is equal to 80 is given. So n value is equal to 80. And the next one here, mean value is equal to, the mean x is equal to 472.36. And the standard deviation value here, the sigma value is given as a 62.35. Clear? And the maximum error value is given as e is equal to 10. So we need these values and in order to find the confidence. So here, first of all, E is equal to Z alpha by 2 into sigma by root n. So this is the formula which you have to keep it in mind. So here E value, sigma, n all are known here. So here E is equal to 10, Z alpha by 2 not known. Sigma value standard deviation is 62.35 and root over sample size 80. Root n value is equal to root 80. And here from this Z alpha by 2 we need Z alpha by 2 is equal to 10 times of root 80 by 62.35. So this value is equal to 1.73. So we got Z alpha by 2. So what is it we have to find? We have to find the confidence with that point interval estimation. So from the normal table, so here the area corresponding to Z alpha by 2 is equal to. So let me show you. See the area under the normal distribution. This is 1.43. See here, this is the normal distribution table and this is 1.43. So under 3, the value here will be 0.4236. So here, got it, 0.4236 from the table we have to choose. So the area is in between Z minus alpha by 2 to plus alpha by 2, which is equal to 2 times of 0.4236. So the value here is 0.8472. This is 0.8472 and therefore if you multiply with 100, so we can ascertain with 84.7% confidence. So here the question is so simple that in a study of an automobile insurance, the sample n is given as 80 rupees and mean is given as 472.36 is given, standard deviation sigma is given as 62.35 is given, and here the error value, maximum error value E is given as 10, and we have to find the confidence. For finding the confidence, we have to calculate Z alpha by 2. See here, E is equal to Z alpha by 2 into sigma by root n. This is the formula. If you substitute E value as 10, sigma value as 62.35 and this is root 80. So we got 1.43. From the table it is 0.4236. See here, the area between Z minus alpha by 2 to plus alpha by 2 is 2 times of this one. This is 84.72 and therefore we need the confidence. With what confidence? We can assert the maximum error of rupees 10. So this is 84.7% confidence. The next question here is the mean marks in the mathematics. In the common entrance examination, that will vary from year to year. Clear? In this variation of the mean mark is expressed subjectively by a normal distribution. Mean mu naught is equal to 72 and sigma naught is equal to 5.76. So here the mean and the variance is given. So we need the standard deviation. The standard deviation will be root over. This is 5.76. Clear? And next one, first one, what probability can we assign to the actual mean marks being somewhere between 71.8 and 73.4 for the next year test? So here x values are given here. So here, from the question, first of all, what is given here? The mean value is given as a 72. The mean mu naught value is equal to 72 and the standard deviation is given as root over 5.76, which is equal to 2.4, and n value is equal to 100. So n is equal to 100 is given. See, where it is 100. So here 100 students. So here it is 100 students here. So n is equal to 100 students is given. So as you know that z is equal to x bar x minus mu by sigma. Clear? So here what is x bar here? So x is equal to, for one time we have to take 71.8 and the next time we have to take 73.4. So here if I take x is equal to 71.8, so here z1 is equal to, in place of x we have to write 71.8 minus mu value is equal to 72 divided by sigma is equal to 2.4. The value here is, so clearly it is minus 0.0833. And the next one here is, the next value what we have to take? We have to take 73.4. So if I take 73.4 here, so here 73, so here the same value, that is x minus mu by sigma, z value is equal to, that is 73.4 minus mu. So mu is equal to 72 and sigma is equal to 2.4. If I substitute, the value here is 0.5833. And therefore here, see, here is the normal graph here. So this is the graph. And here in terms of z, so for the first value, that is 71.8, the value here is minus 0.0. So this value is minus 0.0833. So this is the negative side, and this value is nothing but 0.5. So this value is plus 0.5833. So this is the area which we need to calculate. So in this area we have to calculate here. So using the normal distribution here, let x be the mean mark obtained in the common entrance test, then the prior probability, that is probability of 71.8 less than x less than 73.4. So it is in terms of x. In terms of z, it is minus 0.083 less than z less than 0.5833. So we have to find the area of it. So first of all, we have to find the area, that is 0.08. That is 0.0 under 8 value here is. This is 0.0 under 8 is 0.0319. So this is 0.0319 from the table, and this is 0.5 under 8. So this is 0.5 under 8 value is, this is 0.2190. This is 0.2190. If I add, the value here is 0.2509 is the value. And the next question here, hope you got it. And the next question here is, construct 95% Bayesian interval for mu if the test is conducted for the random sample of 100 students from the next incoming class, yielding the mean marks of, see here, mean is given as a 70 with standard deviation 8. So this is the second question. We have to find the Bayesian interval of 95% confidence here. So for the constructing, see here, for the next year. So n is given as 100 students, and x bar is given as 70, and sigma naught is given as 2.4, and mu naught here, the previously we got as 72, and sigma is equal to 8. So here the posterior mean, the formula here is so simple here. Mu naught is equal to, see here, so this is the formula here, n x bar mu naught square plus mu naught into sigma square by n into sigma square into sigma square. So here every value is ready here. So n value is equal to 100, x bar is equal to 70, and sigma naught square value is equal to 2.4 whole square. Mu naught is equal to 72, and sigma square is equal to 8 square by n 100, and this is a sigma naught square is 2.4 whole square, and sigma square value is equal to 8 square. So we got 70.2. So here the mu1 value we got as 71.2, and here the posterior standard deviation. So this is also the next formula here. For the next year, sigma 1 is equal to root over sigma naught square by n into sigma naught square plus sigma square. So if I substitute each and every value here, so sigma, what is sigma here? 8 square. Sigma naught that is 2.4 whole square by n 100. This is a sigma naught is equal to 2.4 whole square, sigma is 8 square. So we got the value as a 0.76. So this is nothing but sigma 1. So 95% Bayesian interval for mu is given as, see here, mu 1 plus z alpha by 2 into sigma 1. So what is mu 1 here? So mu 1 value is very clear as a 70 point. See here, mu 1 value is equal to, this is a 70.2 and sigma 1 value is equal to 0.76. So here, this is a 70.2 plus or minus. For 95% confidence, z alpha by 2 value is equal to 1.96 and into this is 0.7589. So if you multiply and if you subtract for one time, so this, if after multiplication we got 1.4874. So if you subtract, we'll be getting 68.71. If you add up these two, this is 71.69. So this is the interval here, that is Bayesian interval for 95% confidence is 68.71 till 71.69. And what is the third question here? The third question is, what posterior probability should we assign to the event of part 1. See here, we have to take the details of part 1 here. So for that, mu 1 is equal to 70.2. See here, 70.2 and sigma 1 value is equal to 0.76. When x is equal to 71.8, see here the details of the part 1 is 71.8 and 73.4. See here, 71.8 and 73.4. Z is equal to, as you know, that is x minus mu by sigma. Z value is equal to. So if I take 71.8 minus, this is a 70.2 by, this is sigma value 0.76. The value here is 2.105. And here, if you take 73.4, this is in place of x as 73.4 minus mu value is equal to 70.2 mu 1 and sigma 1 is equal to 0.76. The value here is approx 4.21. Then for the posterior probability is equal to, this is first part, that is 71.8 till 73.4. In terms of z, it is 2.105 less than z less than, see here, this is 4.21. So as this is the diagram here, the diagram is also so simple. So this will be, this is 2.105 and this value is equal to, this is 4.21. So in between, so z lies between these two values here. So in order to calculate this one, 0.5 minus, this is 2.1 under 0. So from the table, this is 2.1 under 0 is 0.4821. See here, this is from the table, normal distribution table. So this is 2.1 under 0 is 0.4821. So here, if I multiply here, this will be 0.5 minus 0.4821. The value here is 0.0179. So this is how we have to solve all the three parts here. And the next one here, the next question here is, in a sample size, so this is 32, in a sample size, n is equal to 144 and the standard deviation sigma is equal to 4 and the mean value is 150, then 75% confidence interval for the mean is. So it's also very easy. So n value, it is very clear as 144 and sigma value is equal to 4 and x bar is equal to 150 and 95% confidence interval z alpha by is equal to 1.96. Here is the formula, that is x bar minus z alpha by 2 sigma by root 10 comma x plus x bar plus z alpha by 2 sigma by, this is root 10. As you can see, n is equal to 144, sigma is equal to 4 and x bar is equal to 150 and z alpha beta is equal to this one. As you got an idea, that is x bar minus, this is z alpha by 2 into sigma by, this is root 10 comma x bar plus, this is z alpha by 2 into sigma by, this is root 10. So these are the intervals here. If you substitute, x bar is equal to, what is x bar here, 150, z alpha by 2 is equal to 1.96, sigma value is equal to 4 and root 10 value is equal to root 144. So minus for one time and addition for one time. So here This is 150 minus 0.65 and this is 150 plus 0.65. This is 149.35 for one time and 150.65. So this is the confidence limits interval. And next one here is a sample of 11 rats. See here, how many rats are there here? 11 rats. So this is 11 rats from a central population had an average blood viscosity. So here the mean value is given as average. Mean value is given as 3.92 and the standard deviation value is given as 0.61 and we have to estimate this one. So which one we have to estimate? 95% confidence limits in the mean blood viscosity of the population. Here what all are given here? So it is very clear that n value is equal to the population value, n is equal to the sample value 11 and z alpha by 2 for 95% confidence is 1.96 x bar. So the average value is 3.92 and sigma value is equal to 0.61. So we need to calculate 95% confidence interval, that is x plus or minus e. What is e value? Z alpha by 2 into sigma by, this is root n, as it is very clear, that is x minus, this is z alpha by 2 into sigma by root n. One limit, this is x bar plus this is z alpha by 2 into sigma by this is root n. So here what is x bar here? X bar is 3.92 plus or minus z alpha by 2 is nothing but 1.96 and this is a sigma value. What is sigma here? 0.61 and this is root 11. So the value here is root 11 here, and if you calculate the value, so for minus for one time and addition for one time. So what is root 11 here? 11 root, sorry. So root 11 value is equal to, this is 3.3167. So this value is 3.3167. 3.3167. So here this value will be 3.92 plus or minus 1.96 into this value will be, see here, this is 0.61 divided by, this is 3167. The division will be, see here, this is 0.1839. So if I multiply, this is 1.96 into this is 0.1839. The value here is 3.92 plus or minus 0.3604. So one time we have to subtract and one time we have to make an addition, that is 3.92 minus this is 0.3604. The value here is 3.5596 and the next one is 3.92 plus this is 0.3604. The value here is 4.2804. So this is the interval here. So this is the interval here. So this is root 11. So this is how we have to find the 95% confidence interval. Likewise, you have to calculate what is asked and what is it is given. So we have to segregate what is given and what is to be found, and simply we have to use the formula, we have to substitute, use a calci, and definitely you will get a clear answer. Thank you so much for watching and staying till the end. Here ends the estimation chapter from statistics, and I'll be uploading a new topic from tomorrow. Thank you so much. Please have a look at those videos. Definitely it will be very helpful, and please share it with as many friends as you can. That is the greatest help needed to this channel. Thank you for staying till the end.